Hey, welcome to Pomodoro Joe for, let's see, it's Friday, October 27th, 2023. Today we're looking at LeetCode problem number 5, longest palindromic substring. This is a medium problem. Given a string, S, return the longest palindromic substring in S. That's the whole problem. Now, a palindromic substring is just a substring that is a palindrome. And a palindrome is just a string that is read forward or backwards, and it's the same. So let's see. Our example here, the string is BABAD, and the output is BAB, because BAB is spelled BAB forward and BAB backwards. All right? You could probably also return ABA. That would work too. Oh, it says, yeah. All right. Example 2, CBBD. Well, it looks like the best we could do is BB. You could have BB reading left to right or BB reading right to left. All right, and our string will be of length between 1 and 1,000. Okay, so let's put 25 minutes on the Pomodoro timer and we'll get started. So for this one, I'll probably do this recursively. Now we'll start with a left and a right index. That'll start at 0 for the left index and the length of our string for the right index. And then we'll have two options. We either move the left to the right by one step, or we move the right index to the left by one step. So let's do this. Let's see here. We'll have some recursive function. We'll call longest palindrome recurse. It will take a left and a right. All right. And let's see. All right. So I guess we'll create some substring of S here. So this will be like sub S, and that's going to be our string from the left index to the right index. Now we have to go right index plus 1 because this slicing is not inclusive on the right-hand side here. So the left to the right plus 1, that's our substring. Now if the substring is a palindrome, so let's see, if sub S is a palindrome. Let's see, we'll have some function here, is palindrome. Sub S. So if our substring is a palindrome, then we can just return our substring. Cool. Now if it's not a palindrome, then we have two options. We can move our left index to the right by one step, or we can move our right index to the left by one step. So let's do that. Option 1, we'll do a recursive call on longest palindrome recurse on left plus 1 and right. And option 2, that's going to be left and then right minus 1. And then we just return whichever option gives us the longest answer. So we'll return option 1 if the length of option 1 is greater than option 2. Otherwise, we return option 2. And we need to kick the whole thing off by calling longest palindrome recurse, passing in 0 for our left index and the length of S minus 1 for our right index. Now we don't have this function is palindrome, so let's define that. Now there's a bunch of different ways we could do this, so I'll do it the easiest way first. Is palindrome. So this will take some string. Let's see, I don't want to call it S, so I'll call it, I don't know what I'll call it, X. All right, so the simplest thing we can do is just compare our current string to the reverse of the current string. So we can just return X equal to the reverse of X. So that's X sliced backwards in steps of -1. So this is just going to take X and it's going to compare it to the reverse of X. If it's the same, that means this is a palindrome. If it's not the same, it will return false, and that means it's not a palindrome. Cool. And let's see, I think that should do it. Now we might want to do some bounds checks to make sure that left doesn't go out of bounds and right doesn't go out of bounds, but I think when left is equal to right, this should return true, so we'll never get to the point where we actually, I guess, exceed our bounds. So let's just try it, see how we do. All right, seems to work. Let's see if we can pass all the tests. time limit exceeded. And as you can see, this is a pretty long string, but it's nowhere near 1,000 characters. So we only get 44 out of 142 test cases. So we'll use this test case. And let's see, one simple thing we could do. We're not actually using dynamic programming or caching for either of these functions. Let's just add caching to these functions. So at cache, we'll just cache out every time we call this function. If we call it with the same string or the same x, we'll already have cached the answer and we can just return right away. So we can save a bunch of processing there. Same thing here. So let's do this. All right, let's see if this saves us anything. Okay, so that does help. So now we're passing this test case we weren't passing before. Let's try it one more time. And now we have a memory limit exceeded. Now this caching only works if it can store these values in memory, the return values for this is palindrome and this longest palindromic recurse. If you can store those essentially argument value pairs in memory. So we're running out of memory here. We do better. We beat 53 out of 142 test cases, but we're still nowhere near close to beating all the test cases. So we'll use this test case. All right, so this solution is probably not going to work. One big problem here is this recursion is going to take a long time. Now I can see two potential issues here. Number one, this recursion, because we have to call this first option first and then the second option, this is going to basically explore all of the options where we move the left first, all the way down to it gets to essentially one character before it starts returning back up. So it's possible that we're finding palindromes along the way, but we still have to finish out this entire sequence of recursion before we even start option 2. So this is an exhaustive search when we really kind of want to exit as soon as we find the first longest palindrome. So that's one problem. The other problem with this solution is that for every left and right combination, essentially every single character in our string, every left index and every right index could be a left or right index in our palindrome. So that means for every character in our string left, there's another character in our string right that could be the, I guess, pair to that left, which is essentially an n times n solution. So that's an n squared solution. So is there a way to do this a little bit better? One thing we could do is instead of doing this recursively, we could do this iteratively. We could keep a queue or a stack. We could push our left and right indices into this queue, working our way in from the left and the right simultaneously, or maybe not simultaneously, I guess. Move just one step at a time from our left or our right, check our answer, and we could always exit early if we get the answer or if we get a palindrome early. So that's one thing we could do. Another thing we could do is instead of moving in from the outside, we could move out from the inside. So what if we had a function that, given an index, it will treat that as sort of the center of our palindrome, and we'll search outwards from that index to see if we can find a palindrome. Now, if that's the case, we can go through every character in our string just once, looking for the longest palindrome with that character or pair of characters at its center. And in that case, that is an O of n solution because we just go through every one of our n characters looking for palindromes. Now, it's a little bit more complicated than just saying it's O of n because we do have to do some searching outwards, but it should reduce this enough that maybe we'll pass. So let's try that. All right, so we'll just get rid of this. Okay, I'm gonna build, I guess, the core loop first, and then we'll build sort of the helper function after that. Or maybe, okay, here we'll do it like this. Let's assume we have a helper function. Longest palindrome, let's do this. We have a function, longest palindrome, with center at index. All right, and for now I'm just gonna pass. So we have a function that, given an index, will return the longest palindrome that's centered at that index. Okay, if we have this function, if that works, then we can say for every index in range, the length of our string, we'll just call this longest palindrome with center at this index. So this option will be the longest palindrome with center at this index. Now, if this option is better than our best option so far, so let's have some result out here. Our result, we'll just start this equal to s at index 0. So that can be one palindrome, basically a one character palindrome. All right, now if this option's length is greater than our current result length, then we can replace our result with this option. So result, that's going to equal option if the length of option is greater than the length of result. Otherwise, we'll just keep the result. Now at the very end, we'll return our result. All right, so this is our core loop. We're just going to go through every index in our string. So for every character in our string, what if this index were the center of a palindrome? What's the longest palindrome we can make? Then we'll check to see if that option is greater or has a greater length than our current result. And if it does, we'll swap it out and we'll keep going. Okay, now we actually have to write this longest palindrome with center at function. All right, this is going to be a little bit tricky, mostly because there are two types of palindromes to consider. One is where there's an odd number of characters, meaning this index truly is the center, the one and only center character of our palindrome. But it's also possible to have a palindrome with an even number of characters, where the center is not a single character, it's two matched characters. So we'll actually have to do sort of a little bit of work to figure out both of those options. So let's start with the easy one first, and that's where this is the odd character in the middle. So odd length. Okay, so we'll call this option 1, and this is just going to be s at this index. All right, it's a one character palindrome. Now we'll start growing this outwards from this center core. So let's see, we'll say while, let's see, I'll need a left and a right. So our left is just going to be this index, and our right is also going to be this index. So while. So we're growing out from the center, so our left is going to be moving further left. So while left is greater than or equal to 0, and our right is less than the length of our string, because we don't want to exceed our bounds. So while we're still within the bounds, and while these characters are matching, so while the string at left is equal to the string at right, that means we still have a palindrome. So we can advance our left and right. So our left will move to the left, and our right will move to the right. Okay, now along the way, I think I'm actually going to keep track of this option. So let's just set it here. Option 1 will equal this string from the left to the right. And again, we have to do +1 because this slicing doesn't include the right index itself. So we have to do right +1. All right, so this takes care of our odd numbered palindromes, or odd number of character length palindromes. So we'll keep going through. As long as we're in bounds, left is greater than or equal to 0, right is less than the length of s, and while their characters are matching, so that's part of the palindrome, while these characters are matching, then this is a palindrome, so we'll replace our current option with this longer option, and we'll update our left and right. So that's the odd number. Now let's do the even number. So let's see if we have an even length. So for this, we have option 2. Now I'm just going to set this as an empty list to begin with, because I don't really know what it is. Or maybe I'll do an empty string, because I don't really know what this is going to be. Now the left is going to just be equal to our index. Let's assume that the left one is our index, and the right, well, that's going to be index +1, because we have matching pairs here. Okay, and then it's very similar. So while, actually I'll just copy this because it's so similar. Okay, so while we're still in bounds, then we'll check. Let's see. While the left is greater than or equal to 0, and while right is less than the length of index, we'll check the left and the right. This is option 2 now, so let's see. Option 2 will be this substring, and then we'll just advance our left and right. Now at the very end, we have two options. Which option do we return? Well, we just return the one that has the longer length. So we'll return option 1 if option 1 is longer than option 2. Otherwise, we'll return option 2. All right, now this is not super efficient. This has some repeated code in here. This also has certain things like we're calling length on string multiple times when the string's length doesn't really change. We could just store that once. We could call this once and then store it. And then we're also replacing this option. We're like making these slices. We could wait until we exit out of this loop, then double check that we have a valid left and right, and then set our option so we don't have to do this slicing all the time. Same thing here. But for our first pass, let's just go with this. Okay, let's see if this works. Let's see, option 2. Oh, I have a bad indent. Let's see what I did here. Yeah, look at that. This whole thing is indented. Let's check this out. Boom. This whole thing got indented. Weird. All right, let's try this. I'm not really sure how that indentation got so badly messed up. All right, let's see if that works. And none of it works. Okay, let's see, what did we do wrong? This indentation is all wrong. Man, let's fix this indentation here. Man, what is going on with this indentation? All right. My apologies, this will take a minute to fix all these indents. Okay, hopefully that will have done it. Let's see. Hey, there we go. And it looks like we're passing these test cases we weren't passing before, so let's give this a shot. And we pass. All right, so after a couple failed attempts, we are passing. We don't have a great solution, but it's passing. We're at a 49% for runtime and a 32% for memory. And it looks like we're solid in the middle of all of the solutions. So we could look in here to see how other people do this, but I'm guessing it's going to be similar here. Let's see. Oh, this one's got a clever solution with an early out. So they just check right away if this string is a palindrome. It just returns the string. That's pretty sweet. Let's see. They're doing similar things with right and left. Oh, but they're being very compact and very efficient about the way they're doing this. So this is definitely a good solution. It's the best solution in terms of runtime. It's difficult to understand just by reading it, but it's a good solution. All right, one thing I haven't really done is sometimes you can click through here. Oh, it looks like the last two solutions are exactly the same, but this one has a comment. All right, you can click through and check out other people's solutions. A lot of these look very similar. Anyway, I think that's it for me. I'll let you check that one out on your own. Okay, so I think that is it. Our initial solution was a recursive solution, but it just wasn't fast enough because it was an O of n squared solution. Now our second solution, we were able to do this in an O of n runtime by selecting our center and moving out instead of our O of n squared runtime, which was checking the outside bounds and moving in. All right, so I guess that's it for me. Hope you enjoyed that. Hope you had fun. Hope you learned something. Hope you can go out and write better code.